Hello students, welcome to the session of curve surveying. In this session, we'll be going to discuss a topic on setting of simple curve. Now, if we want to set a curve, generally we will be using two methods. One is the linear method and second one is the angular method. Linear method will be carried out only by chain and tape and used when high degree of accuracy is not required and when the curve is short. Whereas the angular method is carried out by using the instruments such as the theodolite or maybe the total session. It is used for the higher accuracy and for long curves. Now if you want to set a curve, first we should know what all essential points we have to set in a curve. So it is essential to locate tangents, point of intersection, point of curve and point of tangency. Now let's discuss how to set a tangents. So first we have to fix the directions of straights and produce to meet a point V. Now in this diagram if you see, these are the straights which are called as the tangents. First this tangents will be fixed as per the directions randomly and it will be joined at the point of intersection V. Then at the point V the theodolite is set up and the angle of intersection will be measured. Then the deflection angle will be obtained by subtracting the angle of intersection by 180 degrees. Now once we got the tangents, we have to calculate the length of the tangent. That is the length of this tangent, which is called as the back tangent, and the length of the forward tangent. It is given by the formula r into tan delta upon 2, where r is the radius of the curve and delta is the angle of the curve. Then measure the length, tangent length Vt1 and Vt2 from the intersection point by measuring the distance t and thus located t1 and t2. So this t1 and this t2 will be located by measuring the length from point of intersection. So this length will be equal to length t. This length also will be equal to length t. Now point of curve and point of tangent chainages are determined from the known chainage of point of intersection. So the chainage at t1, that is point of curve, is equals to chainage of pi minus t. That is this chainage minus the length of the tangent. Then chainage at the point of tangent or t2 is equals to chainage of pi plus this length, that is the length of the tangent. And the tangents are located with greater precisions. Now once we set the tangent points, that is the point of intersection, point of curve and point of tangency, next is we have to set the peg intervals. Now what it is, for ease of setting, pegs are inserted on the curves at regular intervals from beginning to end. Now for in this diagram, this is the curve. On this curve, the points will be located, say as T1, E, F, G and continued. So these points are called as the peg points and the distance between these points are called as the peg interval. Okay, that is the intervals are called as the peg intervals. And the chord, that is the line joining from one peg to another peg, is called as the normal chord or full chord. So in this diagram, C1, C2, C3 are called as the chords, may be called as the normal chords or full chords. The length of normal chord is generally 20 meter. Since we are using a chain of 20 meter, it may be taken as 20 meter, or if you are using 30 meter, we can take it as the 30 meter. The first chord joining T1 and the first peg is called the subchord, and similarly the last chord joining the last peg and T2 is called the subchord. Now in this case, the chord between T1 and E is the first chord. It is called as the subchord. Now why the first chords and last chords are called as subchords? Because as we know, the length of normal chords is 20 meter. But the length of the first chord and the last chord will be lesser than 20 meter. Why? Because the chainage at T1 and the chainage at E, if the difference whatever we will get, it will be lesser than 20 meters. Now for example, now if the chainage at T1 is suppose 101.65, now at the chainage or the next point E should be in such a chainage that its it should be a round figure. Now if we are using a 20-meter chain, now if here it is 101.65, here it should be a 120 meter. Now what the difference between 120 and 101.65? That is something around 19.35 will be the length of the cord, which is lesser than the 20 meter. So in order to get the round figure at the point E, okay, we have to keep this length as the lesser than 20 meter. So it is called as the subchord. So always the length of subchord will be lesser than the length of the normal chord. Now first we will be going to study how to set the curve using the linear method. So following are the methods which will be used to set a curve by the linear methods, that is using chain and tape. First is by offset or ordinate from the long chord method, by successive bisection of arcs or chords, by offsets from the tangents, by offsets from the chord produced. Now first we'll be going to study how to set a curve by using long chord method. So for this, here this is the diagram which we have to prefer. So let R be the radius of the curve, O naught be the mid ordinate. So this will be the mid ordinate as we studied the basic elements. This is the mid ordinate, that is CD in this diagram. OX the ordinate at the distance x from the midpoint of the curve. So this is, if this is the midpoint of the curve, at regular intervals we have to fix the ordinates. So this in the regular interval coordinates are called as treated as OX, which is at the distance x, that is the peg interval. T1 and T2 be the tangent points. Then L be the length of the long chord actually measured on the ground, that is the distance from T1 to T2. Now what we have to do is bisect the long chord at point D. So this long chord has to be bisected at point D. Now we'll get the triangle OT1D. So from this triangle, if we use the concept of hypotenuse, OT1 square plus T1D square, sorry, OT1 square is equals to T1D square plus DO square. Now what is T1D? It is half of the long chord length, that is L upon 2. What is DO? DO is taken as CO minus CD, that is CO minus CD. Now what is CO again? It is the radius of the curve. Okay. Minus CD is what we have taken, O naught, that is the mid on it. So it will be L by 2 the whole square plus R minus O naught the square. Now if I resolve this, I'll get the equation has, that is the formula for mid ordinate has R minus square root of R square minus L upon 2 the whole square, where R is the radius of the curve, L is the long chord distance. Now let's discuss what is the formula for the OX. So in order to calculate the ordinate OX to any point E, draw the line EE1 parallel to the long chord T1 T2. So we are going to draw a parallel line which is parallel to the T1 T2 EE1. Now OX is equals to EF, yes, which is equals to E1D. In this picture if you see, OX is equals to EF is equals to E1D. Now E1D is how we can write with respect to O, E1O minus DO, E1O minus DO. Now E1O, what we'll be doing is we have to take this triangle, that is E1OE. Again if we use the hypotenuse concept, we will get the formulas like this way, that is square root of hypotenuse square EO square minus this square EE1 square minus DO. How I can write? Again with respect to CO minus CD. Okay, CO minus CD. Now E, again coming to this equation, now EO is what? It is the radius, so R square minus EE1 is what? It is a peg interval X, at what distance I'm going to take a ordinate, minus CO is what? Again R, and CD is what? Mid ordinate, that is O naught. So if I substitute, I'll get the formula for OX, that is square root of R square minus X square minus of bracket R minus O naught. So this is a formula what we have to use to calculate the distance OX at the interval X. Now if we want to set the curve on a ground, first what you have to draw is the long chord we have to draw on a ground. then this long chord we have to divide it into an even number of equal parts. For example, if the length of the long chord is 100 meters, then if I take the peg interval as 10 meters, so into 10 equal parts I have to divide this. Then at the center will be the mid ordinate, and at every first, second, third, fourth, fifth left side and right side also first, second, fourth, fifth will be the ordinates at the distance of respectively 1 meter, 2 meter, 3 meter. So at every uh, distance of x we have to calculate the ordinate distance and we have to note down the x values. Then at respectively those distances have to set on the ground. Then whatever the ordinates we will get, we have to join the ordinates by smooth curve to get a simple curve. So if I show a small example how the curve will be drawn. So in this case, so this is the long chord, that is in this diagram you can see here, this is the long chord which will be set on the ground first. Then depending upon the ordinates and peg intervals, the points will be marked. If it is the 100 meter, so here 50 meters and here 50 meters, at the halfway it will be marked. The center will be the mid ordinate O naught. The whatever value will be getting, it will be marked, and respectively O1, O2, O3, O4, O1, O2, O3, O4, that is up to O5 here left side and O5 right side will be marked, and their distance respectively will be measured on the ground. Then with the smooth arc, the curve will be drawn and joined. So this is how the method is followed using the long chord method. I hope you understood the topic. In our next session, we'll be discussing the problems on the offset by long chord method. Thank you.